Those of you with me right now, we'll get started in a few minutes. Feel free to message me on Remind if you got questions. We will start with just the packet I passed out today. And that's it. So we won't be here too long. Probably about 30 minutes, I'm guessing, just to do some last minute review. Kind of focusing on the ones I pointed out in class today that were a bit, in my opinion, the hard questions. So we'll go over balancing, the types of reactions. We'll go over how to solve these types of problems, which again they're easier than you think, and empirical formula for sure, just to go through those steps, and naming and formula writing, which is always fun. And I might make up a few extra ones to do with you, just so we can get some extra practice in. But we'll get started in about a minute or so. Thank you for tuning in if you're here. Hopefully someone is here, and I'm not just talking to nobody. But we'll see. So we'll get started in a couple minutes. Text me on Remind if you have any questions, or if you want me to start with a specific question. It'll be a bit more in your shoes tonight, just to ask any questions you got. It is not past your bedtime. Whoever just texted me that. So we'll get started in a couple minutes. I'll probably start with question 1, get right into naming and formula writing, just because it's something that doesn't go away. It's going to pop up more and more throughout this quarter. So it'll be good to review, and then we'll get going here. Hopefully you don't have too many tests tomorrow, because I know your B-Day teachers are probably trying to squeeze in a test before winter break. I think it's a pretty fair test. I think you have a good chance of doing well on this. You just got to think, take your time. It's like all math and numbers, so it's really easy to make a silly mistake. But you're going to do great. And yeah, so again, if you have any questions, text me on Remind. If it has anything to do with this, little skills I can statements of everything that's on the test tomorrow. If you found this to be pretty easy or doable, then you'll be fine. It won't be too different. So I'll get started in about a minute, but as I just kind of sit here and talk awkwardly to try to pass the time. Mrs. G is also doing a live review right now with her calculus class, and I hear my dog somewhere. She's all upset because Mrs. G is in the office, so she closed the door, and Harper just wants to go say hi, but I don't know where she went. Where are you? I hear you. Oh, well, she's somewhere. Anyway, so those of you just joining us, that sheet I passed out, skills needed for the test tomorrow, just going over literally everything that's on the test. Yes, you need to know the type of reactions. That's number 8. I can balance and identify. So read these carefully. Whoever just texted me. The end. And in case you're not watching, I'm just going to text you back. All right, so we'll start with question 1. Writing a formula. So determining the gram formula mass, I think you guys got down pretty good. Take all the atoms, look up on the periodic table, see how much each of them weigh, and you're good to go. There's no issue there. Writing a formula is always the big issue because we refuse to check your charges. So when you have sodium sulfate, the first thing you should do is look up sodium, write down its symbol. Step 1, sodium is Na, not S. S is sulfur, so don't make that mistake. If you're not sure, if you're afraid, if you're like, I don't remember what the symbols are or what they stand for, go to Table S. Table S has all the symbols of the major elements and what they stand for. So don't think you have to memorize these. It's helpful to memorize them because it gives you speed, makes your life easier, less page turning. But if you're in a bind and you're like in the test mode, and you got a little anxiety, and you're like, oh my God, what's S? What's Na? I forget. Just look it up. So when you look up sodium, you'll see the charge given is +1. Sulfate ends in Te. So anytime you go to table E, since it ends in Te, we're going to go to table E. The trick here, so you don't get confused, is to take each one of these and put them in parentheses with the charge on the outside, so you don't accidentally do 3 times or 4 times 2 or anything like that. So I went straight to sulfate. So sulfate is SO4 2-. So I'm going to write SO4 2- here and put it in parentheses. And then from here, if the charges don't match, which they don't in this case, take each number, not the charge itself, just the number. This is a trick to try to balance out the charges quickly. Take each number and crisscross applesauce. So your formula ends up being Na2SO4. Now to find the gram formula mass, I sent out the key to this on Remind. It's pretty easy. You add up your 2 sodiums, then your sulfur, and then your 4 oxygens, and you'll get 142 if I'm not mistaken. So check the key for that. I want to review formula writing just because that's the hard part, and that's where we tend to mess up the most. The next one, iron 3 nitrate. This is actually easier in a sense because you kind of have less work to do. So it says iron 3. We get confused with this 3 constantly. We keep wanting to do this, which is a no. That is not what that's telling you. It is telling you that you have an iron and it's charged +3 or 3+. Either one, it doesn't matter. And the reason that exists when you name something with iron, because if you look up iron, you'll notice that it has 2 charges. So when you name a substance like iron or cobalt or manganese or nickel, if there are these positive ions with multiple charges, you need to indicate which one you have. Do you have the iron that's charged 2, or do you have the iron that's charged 3? Do you have the cobalt that's charged 2, or the cobalt that's charged 3? The reason we don't do these with the negative species is because we just pick the top most often used negative charge for each of them. So we don't really worry about it. So even something crazy like nitrogen with all these oxidation states, or as we've been calling them in class, charges, you end up picking -3 a majority of the time. So we don't really do that for the negatively charged ones. We only do it for the positively charged ones. So when you go back to the question, and it says iron 3, that means you have an iron that's charged +3. Nitrate ends in Te. So that's from table E. So you put it in parentheses, you look it up on table E, and you'll find out that it's NO3, -1. So we have a -1 charge on the right, a +3 charge on the left. That's not the same. They need to balance each other out. So you bring the 3 down, you bring the 1 down, crisscross applesauce, and you get FeNO3, 3. So that's the final answer for the formula. FeNO3, 3. The issue now when you're doing the gram formula mass of this is not that it's hard, it's just that you might make a silly mistake if you don't take your time. So when you have FeNO3, 3, the trick here is to remember that this 3 distributes to the oxygen and to the nitrogen, but not the iron. So when you're adding them all together, you're going to take the mass of the iron plus the mass of 3 nitrogens plus the mass of 9 oxygens. So you distribute that 3 like you distribute any number in math class. It's a multiplication operation, not an addition or subtraction or anything like that. From there, again, when you do the gram formula mass, add them all together, and that's it. That's all we're looking for. Yay. I'm going to skip 2 for now, come back to that later, and I'm going to go down to number 6, and I'm going to focus on the second one, which is the one with chromium and chlorine, and then I'll look over the other ones. I'll do the other number 6 later. Just a comment on this one. People were kind of upset in class that the numbers you were getting were so small as you were working through this. That's okay. Don't worry about numbers being small. They're kind of small in the first place. On the test tomorrow, they're probably not going to be this small, so don't worry about it. But when you're trying to find the empirical formula and you're given 2% of 2 random atoms or 3 atoms or anything like that, you got to take their percents and you're going to assume that they're grams. Because if you notice, the percents add up to 100 anyway. So if they add up to 100, we might as well assume that we have 100 grams of the compound, because that just makes our life a little bit easier. So we're going to take our chromium. We're just going to do the work up here because I have room. And we have, what was it, 32.8 grams of chromium. So that's your given mass. And we can plug that into the moles equation because we're trying to find moles. So moles is the second formula on the reference table because it's one of the most used formulas you're going to have. And you're going to take the mass that's given in the question and put it over the mass of the formula in grams. Gram formula mass. So when you look up chromium on the periodic table, you're going to find out that chromium 52 grams. That's a horrible 5. 52 grams. And when you divide these two numbers, you'll get 0.631 moles. Then you're going to do the same thing for chlorine. Chlorine is 67.2 grams in the problem. Go to the periodic table, you'll look up chlorine, and it weighs about 35 grams. And then for this, you'll get 1.92 moles. So big mistakes people make initially when they're trying to solve an empirical formula question like this is that they'll go here, right to the problem, and the first thing they'll do is divide those ones by the smaller number. So they'll do 32.8 divided by 32.8 and 67.2 divided by 67.2. What you're doing is trying to get a formula. So when you look at any formula, like C4H8, these numbers represent moles, not mass. So we have to get away from the mass they gave us and try to get to moles, because moles will give you what you have in the formula. So while here, these are numbers and they're in moles, you can't have a formula that's just Cr 0.3631 and Cl 1.92. We write formulas with whole numbers, not with decimals. So a trick to get the ratio faster, rather than trying to sit there and figure out how many times does 0.631 go into 1.92 off the top of your head, is to just divide each one by the smaller number. And when you do that, your Cr is obviously going to be 1, and your Cl should be 3. And that's it. If you get to this step on a question where you get to the step where you're dividing by the smaller number, and let's say chlorine wasn't 3, let's say it was 2.5. If it ends in 0.5, you can't round that up or down. That's exactly in the middle. How do you know when to round up? How do you know when to round down? You don't, because it's right in the middle. So you're just going to take each number and multiply it by 2, and then you would get Cr2Cl5. But that only happens when the number, after you've converted to moles, and after you've divided by the smaller number, so you're at this step, when that ends in 0.5, any of the numbers ends in 0.5, multiply every number you're given by 2, and that will round your answer up to the appropriate place. And that's it. I would say tomorrow, in terms of empirical formula, you'll probably see one question like this, where you're given percents and you have to get to grams, or get the formula. Maybe 2, because it might pop up in both a short answer and multiple choice, but at least 1. You'll also see one like 5, where 5 should be pretty easy. If that's the molecular formula and need to reduce it down to the empirical, just try to figure out what number you can divide each of those by until it's the simplest ratio. So if you divide those each by 4, you'll get CH2. And that's all that one's looking for. So that should be an easy point, hopefully. All right, balancing equations. I'm going to do identifying reaction type first, because I'd say at least 80% of you are pretty comfortable with balancing equations, as long as you put in the time to just kind of work it out. So I'm going to go over balancing equations eventually. Right now, I want to go over identifying the types of reactions. So when you look at this, excuse me, I sneezed. It went away. When you look at these reactions, they're each different. So one of them is not the same as the other two, and so on. The only two you don't see here are synthesis and combustion, which I also think are the easiest reactions to identify, in my opinion. So synthesis is when you have multiple things becoming one compound. So if you're adding all these various atoms and compounds together and then they bond to form one big compound, you have synthesis. Decomposition is the exact opposite of synthesis. You have this big compound and then it breaks apart into its various smaller parts. That is the exact opposite of synthesis. So synthesis brings things together into one. Decomp breaks things apart into more than one. So that should be, hopefully, fingers crossed, the easiest two that you have to identify tomorrow. Now, the other ones tend to cause a little bit of confusion. So I'm going to do single replacement first. So the general idea, the general reaction for single replacement is an atom reacts with a compound to make a new compound and then another different lonely atom. So it's that one I try to do in class a lot with my fingers. So you have a compound here and an atom here, and the atom comes in and kicks one off and bonds to it in its place. And then kicks one off and bonds to it in its place. So there's a lot of this happening. So if you look at these three, the last one, aluminum, comes in, kicks off hydrogen, and bonds to it in its place. And when I say it, I mean bonds to chlorine. So it kicks off hydrogen, see you later, and bonds to whatever hydrogen it was bonding to begin with, and that's a single switch, because the other one didn't switch to bond with something else as well. It just did one switch. One person in, one person out, see you later. Double replacement is somewhat similar, but instead of there being an element or an atom reacting with a compound, it's two compounds reacting with each other. and you'll get a double switch. So if you look at the types of reactions above, the one where there's a double switch occurring would be the one in the middle. The iron and the hydrogen are both switching with each other. The iron's not just kicking the hydrogen off and the hydrogen just goes away. The iron comes in, kicks the hydrogen off, and then the hydrogen comes around and bonds to its buddy in its place. So now the SO4 is with iron and the Br is with hydrogen. So this one was single replacement. This one was double replacement. And then combustion, there's no general reaction for. The reaction for combustion is the same thing every single time. You take some carbon-hydrogen-like compound, anything with C's and H's in it, and react it with oxygen with a little bit of heat, like I did with that soap demonstration. You will make carbon dioxide and water every single time. So, carbon-hydrogen reacted with oxygen, you get CO2 and H2O. CO2 and H2O are always going to be the products of combustion. So combustion is the only one that doesn't have like a general, what does it kind of look like if we had to use just like this example with non-existent elements and compounds. Combustion is very specific, has a very specific reaction that creates very specific products. And those are it for the types of reactions. Again, if you have questions, those of you tuning in, just message me on Remind, and I will answer them on screen as long as there are questions about chemistry. If you have any other questions, I don't know what they would be, you can ask me some other time. But I'm going to come back to 8 just to go over balancing later. So people that are like getting ready to tune out, think they've had enough, I think we got it, and you think you got balancing, I'm not going to do that now. I'm going to do that in like 5 minutes. I want to make sure I cover number 9 just to double check that we understand what's happening here. This is a lot easier than some of you are making it out to be. I think we're overthinking it, trying to do too much. I think you just have to look at what's given and just think about what that means, and you'll be okay. So when you see these stoichiometry problems, which means how are we manipulating our equation to be different, it's all about proportions. So first, I would identify what the problem wants you to look for because you can ignore the rest. So this problem has oxygen and water in it. So I don't care about this, and I don't care about that. I might need to care about it later, but for right now, I'm just not going to pay attention to it. It's just a distraction. Don't worry about it. Who cares? And then the first thing I like to do is take the oxygen and write exactly what it does in the reaction. For every 3 oxygens I have, 2 waters are made. For every 3 moles of oxygen I have, 2 moles of water are made. Big numbers are moles. And you can change the big numbers based on how many ingredients you have. Whenever we do a lab, we almost never work with 1 mole of anything. It weighs too much. It costs too much to use. I don't want to waste any of it. We work and scale it down. So what this problem is doing is exactly that. We're scaling it down. So instead of using 3 moles of oxygen, we're going to be using 0.5 moles of oxygen. How many waters would that make? Would you look at that? That's just a proportion. And most of you are pretty good at cross-multiplying and dividing. Big numbers, cross-multiply and divide, and you'll get x is equal to 1/3. So if you had 0.5 moles of water, or of oxygen I should say, that would create a 1/3 moles, or 0.33 moles of water. And that's all these problems are asking you to do here, is just take a mole ratio and apply it to the question. But let's go over the other 2 just to make sure we're okay. All right, so The next one is carbon dioxide and butene. So I'm going to go in, I'm going to cross out the two I don't need to know because it's just a distraction. And I'm going to say what it's written as in the problem. For every 1 butene, 2 carbon dioxides are made. The problem says, what happens if you have 20 carbon dioxides? How many butenes would that make? And it's exactly like the problem before. We're changing how much product or reactants we have. And when you do that, you will scale everything up or you'll scale everything down. This problem, we scaled down because we took the 3 and made it a 0.5. Here, we're taking the 2 moles of carbon dioxide we formed and pretending now that we formed 20 moles, which is 10 times as many. Or when you cross multiply and divide, you get 20 equals 2x. Divide both sides by 2, and you get x equals 10. So you have 10 moles of butene instead of 1 because we scaled everything up by a multiple of 10. And that's it. It's just a proportion. Don't try to see it in your head if that's not how you're doing it. I try to give more than one way to solve problems because there's more than one way to solve a problem. Some people, when you change these numbers to 0.5 or 20, can just look at the reaction and just, oh, I multiplied it by 10, so I got to multiply everything by 10. Or I divided it by 6, so I have to divide everything by 6. Great. Good for them. They figured it out quick. If you need to take your time, set up a proportion, who cares? Do what you got to do to get the problem right. All right, this deals with butene and carbon dioxide again. So I don't care about you. I don't care about you. I'm going to write exactly what's given to me in the reaction. For every 1 butene, there is 2 carbon dioxides. What happens if I take my 1 butene and now have 5 of them? How many carbon dioxides is that going to make instead? So I scaled this up again. I went from 1 to 5. I've increased how much I have, which means when I cross multiply and divide, I should get an answer that is bigger than 2, and I did. And that's it. That's all you really have to do for these. I'm going to take one of these kinds of questions, these stoichiometry questions, and make it a bonus question tomorrow. There was 2 bonus questions I was thinking about putting on. I think I remember the 2 of them now. Just to make it a little interesting tomorrow, because I want you guys to do well, because I like it when you guys do well. So, those are the ones I really specifically wanted to go over. If you have any questions, I'm going to pause for about 30 seconds to a minute. If you have a very kind of specific chemistry-related question, shoot it to me on Remind right now, even if it's not something on this skills sheet, or if it is something on this skills sheet, like Mr. G, can you go over number 4? Or Mr. G, I don't remember how to do formula writing very well. Can you make up some examples? I'd be happy to. Just got to ask. So I'm going to take about 30 seconds, leave it up to you. If I don't get any questions in the next 30 seconds to a minute, I'm going to go over how to balance these 3 equations, because who never needs help with balancing? Everyone needs help with balancing sometimes. So, well, I got excited because my phone buzzed. And it was just a USA Today headline. Scientists, I'm interested, are about to explore an underwater world that's been hidden for 120,000 years. That's crazy. Maybe I'll take 30 seconds to just read up on this a little bit while you think of all these questions you're going to ask me, because I'm sure there's a lot of them. Pretty interesting stuff. In Antarctica, I knew someone that went to Antarctica. That's it. That's the whole story. It's a pretty interesting place. It's kind of cold, as you might imagine. Cool. All right. Judging by the lack of questions, I'm going to go over how to balance these, and then I'm going to give you another 30 seconds, and if no one says anything, I'm out of here. So, I'm going to start with the one on the bottom just because that's the easiest one to start with because I have the most room for it when I don't have to rewrite anything. So I'm going to draw my line down the middle, preferably using a pen, not a highlighter. And I'm going to say, okay, there's an AL, there's a CL, and there's an H. So you always do H's and O's last. And for AL, I have one here and I have one there, and I'm done for now. I might need to come back later, double check. CL, I have one here, I have 3 there. So that's not even. So I got to multiply this by 3 to make them both 3, which means I got to put a 3 in front of the entire formula. You can't change what you have. You can only change how much of it you have. So don't put the little numbers anywhere. Never do that. Now here's what I say. You need to work back and forth when you do these balancing equations. Because if you look at H, I have 3 here, and I have 2 here. So that's not even. And I need to find a way to get them both to be the same. And I know that 3 and 2 are both factors of 6. So if I multiply this by 2, I'll get 6. And I'll multiply this by 3, I'll get 6. So I got to go back, erase this, and change them both to, that's not right. Yeah, so I got to change this to 6. And I got to change this to 3. Now, some of you are like, oh, I got to the bottom. I'm done. Yay. No, you're not, because what happened when I changed this to a 6? My chlorines changed. I don't have 3 anymore. I have 6 now. So I have to go back. It's a back and forth process. Don't just stop because you got to the bottom. And here I have 3, so I got to multiply that by 2 to get 6. 2. And now my aluminums are off. So this isn't 1 anymore. This is 2, which means I got to multiply this by 2 to balance my aluminums. A lot of the time, it's not just going to be 1, 2, 2, 1, 1 pass through, don't need to check anything. You got to work back and forth. The good part is it's hard to get these wrong as long as you put in the time to figure it out. Just count. The big numbers in front are multiplying. When you have something that says 6HCl, that is literally 6, 2, 3, 4, 5, 6 HCl's. So don't panic about the numbers. Don't get confused by the numbers. Take a deep breath. Take your time. Check all your answers. And you're going to do great. Guarantee it. So, and always ask questions. Asking questions is good. I love it when you guys ask questions. I'm sitting there watching you guys take a test. Not going to say that's the most entertaining thing in the world for Mr. G. So what keeps me entertained? Your questions. All right, I'm going to do the one in the middle. I'm just going to kind of cross this out, pretend like that's not there, and draw a line down the middle here. And we got FeBrSHO. I always do the H's and O's last. So, first, FEs. We got 1, 2. That's not even. Come on. Multiply this by 2. Make that 2. All right. BRs. We got 2 times 3. Well, that's just 1. So I know I got to put a 6 here to get that to be 6. S's. I got 1. And then here I got 3. That's not even. I know I'm going to have to multiply that by 3. H, I got 3 times 2, 6. 6 times 1, 6. Balanced. Oxygen, 3 times 4, 12. 3 times 4, 12. Done. Done balancing this one. So we got lucky here. We didn't have to really do any more checking. Everything stayed the same throughout. It kind of fixed itself. That happens a lot when you push the hydrogens and the oxygens to do that last. So no worries. And I'm going to balance that top one. And if I get no questions on Remind, I am out of here. Out of here. I don't even know if I'm talking to anyone. Anyone out there? That would be weird if you're just talking to no one right now. Like everyone tuned out of this. And I'm literally just here doing this for no one. But that's okay. We're going to chug along. All right. Line down the middle. C-H-O. That's all I got here. Cho-cho. So, let's do this. C, 4, 1. That's not balanced. Multiply this by 4, and you get 4. H, 10, 2. Multiply that by 5 to get 10. Oxygen, I have 2 plus 1, 3. Oxygen here, I have 8. 4 times 2 is 8, plus 5, 13. And you're like, whoa, that's weird. How am I going to do this, Mr. G? It's 2 odd numbers. 13 is a prime number. This is hard. Take a deep breath and look at your numbers on the left again. You have an oxygen with a 2 here, and then an oxygen with just 1. And I think that I can take a number and multiply that number by 2, and then add the number 1 to it, and get 13. What could that number be? I think if I put a 6 here, and I do 6 times 2, that's 12 plus 1, 13. Check, 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 check. Done. And that's it for balancing. So, I'm going to give you a minute. You have any other questions? You want me to make up a question? Whatever. Let me know. If not, have a great night. Good luck tomorrow. Don't forget to study for math or history or English or whatever else you got. I don't know. You're going to do great tomorrow. Ask questions. Hi, ask a question. That's why I'm here, to answer your questions. All right, I'm going to give you 10 seconds. Ooh, it says a 5 there. Wonder what that means. Oh, I got a question. I like it. Number 3. Ooh, that's a good one. Thank you. I should have done this in the first place. You're awesome, person that suggested this. Maybe you'll get 2 treats tomorrow. What? I'm handing out treats? Anyway. All right, so percent composition of water and calcium chloride tetrahydrate. Oof. This requires a little bit of thought. So let's do calcium chloride first because we talked about naming and formula writing a lot. We got to make sure we got that down. So calcium is Ca. What's its charge? +2. Chlorine is Cl. What's that one's charge? -1. Not the same. Crisscross applesauce. 1 goes here. 2 goes there. CaCl2. But we're not done yet. Tetrahydrate. Tetra. Oh boy. What's tetra mean? Is it 2, 3, 4, 25? So all of these correspond to shape names. Triangle, pentagon, hexagon, hept, oct, non, doke. But tetra's the weird one. What's tetra? 4. So tetrahydrate means 4 H2Os. So that's my formula. Calcium chloride, tetrahydrate. So what's the percent composition of water in this formula? So percent composition, don't try to memorize it. It's on the reference table. Part over whole times 100. Right there. So what is the whole? Let's get the whole done first. So the whole is 40, which is your calcium, plus 35 times 2 for your 2 chlorines, plus 4 parentheses. Let's try this again. 4 times 18, because water weighs 18, and there's 4 of them. So that's your whole, that's your denominator. Your part, it wanted the percent composition of water. So your part would be the 4 times 18 up top. And then you multiply that by 100. And you get whatever you should get, because I texted out the key before and I don't remember. You get... Did I send the same picture twice? Looks like I might have sent the same picture twice. I'm going to send out the key correctly this time. Maybe. Where'd that question go? Well, the answer to this is 40 plus 70 plus 72. 72 divided by 182. Should have been 39.5%. Of course, I'm looking over the reminds I sent you, and it looks like one of them didn't send. Let me know if that's right or wrong. There's one. Yeah, I think I sent the same page twice. Mr. G, you silly head. My apologies. Okay, so I think I went over 1, 2, 3. I'll give you the answers to, and I did 5, so I just need to give you the answer to 4. And you should be good. You know, no one looks at that when I send out the same page twice and no one says anything. That's kind of sad. Anyway, the answer to 4, that's your given mass. So moles would be the given mass divided by carbon dioxide's actual mass, which is 44. And then for water, you were given 0.4 moles. I was not given a mass, but I know water weighs 18, and then multiply those two across, and you'll get x is equal to 18 times 0.4. That's it. 30 seconds. You're on the clock. Questions, questions, questions. Wonder how many of you were at the basketball game. Like, I'm not. What's up, Mrs. G? The boys? Who are they playing? What quarter are the boys in? What's the score? Well, how do you know they're winning? Mrs. G, she doesn't know what she's talking about. Let's see what Twitter says. Twitter says 30-24, Toga boys. And the girls already won. Oh, the third quarter is almost over. They only have 30 points? Isn't that really low? Yeah. That is not a lot of points. She's not angry. We're just not in the same room, so we're shouting at each other. One of my students said you sounded angry.
Live streaming with my students.
Do you want to guess who said you sounded angry?
Is it someone I know?
Uh-huh.
I don't know who. Jocelyn?
No.
Who?
Jocelyn said something about bedtime.
Who said I sounded
Kislowski.
Justin, I'm not angry.
Harper! Want to make another guest appearance?
No, she wants my chicken.
Yeah, she does. She has no interest in me.
Go over there.
No, it's okay. It's all right. I don't even know how many people are watching right now. So I sent them the key to this, and I sent them the same page twice.
Oh, gee, you killed it.
I don't know how that happened, because I know I didn't take a picture of the same page twice. So then I went to check my pictures, and I can't. The other photo's not there. So I don't know what I did. But, whoops. What happens? Ooh.
You goofed.
Got a request for the dog. Harp, come here.
Come here. Go.
Harper.
Here.
Hey, girl. Come here, girl. Wow. What are you doing?
You want a treat? Sit.
Harper! She's like, Dad, I don't want to eat a computer. I want to eat this treat. Are you still streaming? Or are you
No,
done?
I'm done.
Yeah, I'm done too. But I'm
all
giving
my
them
kids
time.
are at the game. Come on.
They're probably wondering how long I'll keep this open at this point.
Now it's a game of chicken.
Yeah. All right, so I got a student asked me, we need to clear the air before we can finish the stream. Your go-to funnel cake toppings. I mean, I feel like powdered sugar.
Powdered sugar. Yep.
I don't think I need anything else other than powdered sugar.
I mean, whipped cream and rainbow sprinkles, I won't say no to.
Didn't I get like a crazy funnel cake at Six Flags this summer with like a bunch of stuff?
Yeah, it had soft serve on it. And
soft serve ice cream
bananas, and it was like a banana split.
It was like, yeah, banana split on top of funnel cake.
And then...
Not a fan. It just leads to soggy funnel cake. The best part about funnel cake is that it's warm, fresh, powdered sugar, done. I don't need that. What else do you put on your funnel cakes?
Sardines?
No.
Avocado?
Now you're just making stuff up.
Mm-hmm.
No one puts that on there. Okay, my student agrees that that's all you need.
Classic.
Which leads me to believe he knows someone that like goes over the top with their funnel cakes.
You got that one at 6 Flags.
It sounded good at the time, but that was... I don't know how good I felt after I ate it.
Felt terrible.
That's for
When
sure.
you went on roller coasters.
Yeah. Didn't throw up, though, so that's fine. Chocolate syrup is bang
No.
on a funnel cake. No. I barely like chocolate syrup on anything. I think chocolate syrup is just, like, overrated. Fudge, I'd like. But, again, funnel cake, just powdered sugar. What do we need chocolate syrup for?
You should show them what
It's going to make it soggy. What'd you say?
You should show them what my student made me and challenge them to top it.
What? The cookies? Oh, yeah. Got some... Mrs. G got some chocolate chip cookies and 2 lemon bars. And what does Mr. G get? Nothing.
Nothing.
That's okay. I get it. I haven't gotten any questions about going to stream Fortnite yet, which I'm surprised by.
Did you check your mailbox?
At school? No.
You got a Valentine from like the AV club, and it says like Fortnite champ or something on it.
Never. I've never won, at least alone. Oh, I got the thumbs. We're getting the thumbs down for dissing on chocolate syrup. Mrs. G is joking. No one puts avocado on a funnel cake. More of this nonsense is... Kozlowski just asked, is water wet?
Good question, Justin.
I feel like that's more philosophical than chemical. I mean, is anything at a certain scale? You get small enough.
Whoa.
Right? I mean, am I really touching my fingers? I'm repelling the atoms in my fingers, so am I really touching them? I don't know. See, that's where life gets interesting.
If a tree falls in the forest and no one's around, does it make a sound?
Yes.
If The Bachelor's on, but Mrs. G doesn't watch it, is The Bachelor on?
See, that I don't know. My student says that you're beating me in the subscriber count.
Yeah, I have like 12, so I'm killing it.
You got over double.
I'm pretty much a celebrity.
He said, you got to get on your hustle.
I also teach more kids than you.
That's true. So she teaches like double the kids. She has pretty much double the subscribers.
That's
so
a proportion.
Really, with that handicap, we're basically tied.
Basically. Harper, stop looking at the stove.
All right, the streaming Fortnite comments have started, so I think that's my cue. I'll see you in class tomorrow. Get a good night's sleep. You're going to do great.